So we are here once again for another question. This is also one of the questions in the WASSCE core mathematics. Let's look at how we can tackle this question. So for this question, we are saying ABCD is a cyclic quadrilateral. BC and AD are produced to A. Angle ABC is equal to 2R. Angle CEF is equal to 5R. And angle DCA is equal to 51 degrees. And this question demands we find the value of R and also look at angle ADC. Good. So this is the question we have before us. So let's quickly look at how we can do this question. So we begin with our solution. Good. So before that, let's look at this diagram here. So in the question, we are saying ABCD is a cyclic quadrilateral. So remember in plane geometry 2, we talked about cyclic quadrilateral. It is one of the theorems. So we have A, B, C, D. So we are talking about this. So when we say cyclic quadrilateral, you remember the properties. Yes, so we would apply the properties when you are dealing with cyclic quadrilateral. Good. So the first question says we should find what is the value of R. Now, this is the diagram. We have 2R here, and you can see that we also have 5R here. But there is another angle here which is given, that is 51 degrees, which is given here. So let me do some sketches here so that the whole work becomes easy for us. So let's look at this. So let's look at ABE. ABE. So I'm going to do this ABE. So let me draw that. So we have this A. Don't mind my sketch. It's just a sketch. Good. So let me extend this. So let's say here is my E. Here's my A. And then I have my B here. Then we are saying here is what, 2R. And then there is another line here. So let me call here my D and then my C. But we have this angle as what? 51. And then this particular angle gives us what? 5R. Good. Now let's consider this part. Let's consider this part. Since we have been given this angle as 51, and we can look at this particular angle. Have you gotten that? So if we have 51 degrees here, then it is easy for us to find this particular angle. So you can recall in the plane geometry 1, we say that you see that this is what, a straight line, and you have angles from here. So angles formed on a straight line, the sum of angles formed on a straight line gives us what, 180 degrees. So we can quickly find this angle here. So you let me call this angle A, small a. So how do I get A? So you say that the sum of angles on a straight line gives us what, 180. So I can write A plus 51, which is equal to what, 180 degrees. Good. So my A is equal to 180 degrees minus 51. Good. 51. So let's quickly look at it. So A becomes what? 129 degrees. Good. So it means that this particular angle is what? 129 degrees. So let me go back to the question and put the one. So let me put the 129 degrees there. So I have 129 degrees. So it means this particular angle is what? 129 degrees. Good. Now let's consider this angle here. Let's consider this angle and this angle. Have you gotten that? Good. So look at this angle. Now remember that we are saying ABCD is a cyclic quadrilateral, and for cyclic quadrilateral we always say that the sum of two opposite angles is equal to what? 180 degrees. The sum of two opposite angles. In the first place, what is a cyclic quadrilateral? So we are saying that whenever you have a quadrilateral drawn in a circle or an inscribed what circle, you could see that all the vertices what touches a point on a circle or a circumference on a circle. So once you have the quadrilateral drawn in a circle and the vertices what touch any point on the circumference of the circle, then that is what we call what cyclic quadrilateral. Have you gotten that? So you see that we have A, B, C, D as a quadrilateral, which is inscribed in a circle. Have you gotten that? Good. So for that property, we are saying that the sum of two opposite angles in a cyclic quadrilateral is equal to what? 180 degrees. So looking at this angle, you see that this angle is opposite to this angle. This angle is also opposite to this angle. So let me call here angle B. Let's see, this is angle B. Good. And let me call here angle C. Already we called here A and we got 129. So let me call here small c. Good. So to get this angle, what this property is saying is we should sum these two opposite angles and we are going to get what? 180. So if you sum them, we are going to get 180 degrees. So it means that so my here is what? B and here is C. So B plus 129 degrees is equal to 180 degrees. Have you gotten that? So I have B as 180 degrees minus 129 degrees, which gives me what? 51 degrees. So it means that my B is also what? 51 degrees. Good. So once we know here as 51 degrees, then we can quickly look for R. But how do we get R? Now, you see that ABE is what? A triangle. ABE is a triangle. But we have an exterior angle here. And all these angles you see here, they are the interior angles. Remember also in plane geometry 1, we are saying that we talked about something called exterior angle theorem. Exterior angles theorem. And what does that theorem state? So the theorem states that when you sum two interior angles, the answer you get should be equal to their opposite exterior angle. So the sum of two interior angles is equal to their opposite exterior angle. Their opposite. So looking at these two angles, what is here and what is here, these two angles are opposite to the exterior angle you see here. So the exterior angle theorem is saying that once this exterior angle is opposite to these two angles, then this exterior angle is equal to the sum of these two interior angles. Have you gotten that? Good. So we can sum this to and equate to what the exterior angle. Have you gotten that? So we can write 2r plus 51 is equal to 5r. Have you gotten that? So let's group some like terms. So I can write this as 5r minus 2r is equal to 51 degrees. So I have my 3r is equal to 51 degrees. Then can divide both sides by 3. Then r gives me what? 17 degrees. So the first question, which says we should find the value of r, is answered. So we know that the value of r is what? 17 degrees. Good. So that is our first question. Now let's look at the second question. So the second question also says we should find angle ADC. So let's identify angle ADC. ADC. So angle ADC. So it means that we are finding angle C, where I have placed the small c there. ADC. So we are looking at this angle. But how do we find this angle? We have already said that ABCD is a cyclic quadrilateral. Good. So if it is a cyclic quadrilateral, then that property, the same property we use for here, what still holds for this one as well. So it means that these two opposite angles, the sum of these two opposite angles will give me what? 180 degrees. So I will only write so I will only write 2r plus c is equal to what? 180 degrees. Have you gotten that? But we know this r as what? 17. So I can just substitute my 17 there. Then plus c is equal to 180 degrees. Good. So we can just write what? So 2 times 17 will give me what? Okay, so we get 34. So 34 plus c is equal to 180 degrees. So if I'm to make c the subject, then I'm getting c is equal to 180 degrees minus 34 degrees. So my c is equal to what? So 180 degrees minus 34 gives me what? 146 degrees. Good. So it means that angle ADC is equal to 146 degrees. So very simple. I know this question is very simple to some of you, and those of you who find it difficult to understand this question. So this is the solution to this question. So you can take your time, go through, read. If you don't understand anything, you can go to the comment section and ask your question, and we'll answer you. You can also bring any question that you want us to help you solve, then we will also help you. All right. So my name is Evans Okay. I'm your facilitator. So I would like you to subscribe to my YouTube channel, like and share. So see you next time. Thank you.